Have you ever noticed how when Facebook goes down for a few hours, everyone panics like the entire internet is broken? Or when Amazon Web Services crashes and half the websites you use suddenly stop working? Everyone says the internet is fragile, that one big outage could take everything down. But here's what nobody tells you about what's actually happening during these massive outages. The internet was literally designed to survive nuclear war, not figuratively, actually designed with nuclear attacks in mind. And the way it's built means there's no single point of failure that could ever take the whole thing down. In the next 15 minutes, you're going to understand exactly why the internet is basically indestructible, how it routes around damage automatically like water flowing around rocks, and why those scary news headlines about the internet going down are missing the entire point of how this system actually works. Here's what's really happening when you hear about a major internet outage. Let's say it's October 2021, and Facebook, Instagram, and WhatsApp all go dark for 6 hours. The news is calling it a massive internet outage. Your friends are freaking out because they can't access their accounts. Billions of people worldwide suddenly can't use these platforms. It feels apocalyptic, like the internet itself is breaking. Picture this scenario. You're sitting at home trying to check Instagram. Nothing loads. You switch to Facebook? Same thing. You try WhatsApp? Dead. You check Twitter to see if anyone else is having the same problem, and Twitter works fine. So does YouTube. So does Gmail. Netflix is streaming perfectly. Amazon is up. Your banking app works. Every other website and app functions normally. Wait, if the internet is down, why does literally everything except Facebook's services still work? Think about it this way. When your local Starbucks closes for repairs, you don't say, "Coffee has been destroyed." You just go to a different coffee shop. But when Facebook goes down, headlines scream about internet collapse. That's because most people think about the internet as this single, fragile thing that can break. But that's not what actually happens. What really happens is way more interesting and way more resilient. Everyone tells you to back up your data because the internet could crash. But that's not what the internet does. The internet doesn't crash as a whole. Individual services crash. Specific websites go down, certain companies have outages, but the underlying internet, the actual network connecting billions of devices, keeps running. It was built specifically to never have a single point of failure. And that's exactly what happens during even the biggest outages. Parts fail, but the system adapts. And this matters because understanding how the internet actually survives damage changes everything about how you see technology resilience. It's not about having perfect systems that never break. It's about having systems that keep working even when parts of them are destroyed. Your view of internet vulnerability is probably backwards. You think we need to prevent all failures. But the internet's genius is that it doesn't need to prevent failures. It just routes around them. The average person experiences maybe 10 noticeable internet service disruptions per year. Facebook down for a few hours, Netflix buffering during peak times, your email being slow. But in each of those cases, the actual internet underneath is humming along perfectly. Billions of other connections working flawlessly. It's like being stuck in traffic on one highway and thinking all roads everywhere are blocked. No, just your route is congested. The interstate system itself is fine. So let me show you something. There's this principle I call the mesh mentality, and it's the core of why the internet can't be destroyed. The internet isn't a single cable or a central server. It's a mesh network where every point connects to multiple other points. If one connection breaks, data automatically takes a different route. Like water flowing downhill, if you block one path, water finds another. Here's how it actually works. When you send a message from your laptop in Seattle to a server in New York, that data doesn't take a single predetermined path. It gets broken into tiny packets, little chunks of data. Each packet might take a completely different route across the country. Some might go through Los Angeles, others through Denver, some through Chicago. They all arrive at the destination where they get reassembled. If the Los Angeles route is down, those packets just take a different route, automatically, instantly. This matters because it means there's no cable you could cut, no server you could destroy that would break the internet. You'd have to simultaneously destroy thousands of different routes and servers to even make a dent. And even then, the system would adapt. New routes would form, data would find new paths. It's like trying to destroy a spider web by cutting one strand. The web doesn't collapse, it just has a gap. Think about the team that designed the internet in the 1,960 seconds. They were working for the Department of Defense during the Cold War. Their literal job was to create a communication system that could survive a nuclear attack. If Moscow launches missiles and destroys half of America's communication infrastructure, the military still needs to communicate. So they built a network with no center, no headquarters, no single point that, if destroyed, takes everything down. Your brain struggles with this because you're used to hierarchical systems. Your workplace has a CEO. If the CEO leaves, it's chaos. Your house has a main circuit breaker. Flip it, everything goes dark. But the internet doesn't work that way. There's no main internet server, no central control room. It's genuinely decentralized. Every node is equal. Every connection is just one path among thousands. But here's where it gets interesting. Even within this indestructible system, individual services can absolutely fail catastrophically. And this is where everyone gets confused. When Amazon Web Services goes down, hundreds of thousands of websites stop working. It looks like the internet is dying. But AWS isn't the internet. AWS is a service built on top of the internet. The difference is crucial. Think of it like this. The internet is the highway system. AWS is like one massive trucking company that delivers goods on those highways. If the trucking company's dispatch center catches fire and all their trucks stop running, you'll notice that a ton of products don't get delivered. But the highways themselves are fine. Other trucking companies are still making deliveries. You can still drive wherever you want. The infrastructure didn't fail. One big user of that infrastructure failed. Now, this next pattern is particularly sneaky because it involves how traffic actually moves online. There's this thing I call the route around instinct, and it's baked into the fundamental protocols of the internet. When data packets are traveling and they hit a failed connection, routers, those devices that direct traffic, automatically redirect those packets to working connections. No human decides this. No central authority gives permission. It just happens. Pay attention to this. Every router on the internet constantly shares information with nearby routers about which routes are working and how congested they are. It's like if every intersection in America constantly told neighboring intersections about traffic conditions. When a router detects that a connection has failed or is overloaded, it updates its routing table and starts sending traffic elsewhere. Within seconds, the entire internet knows about the failure and has adapted. This is why when a major undersea cable gets cut, and this happens multiple times per year, most people never notice. Traffic that was using that cable automatically gets rerouted through other cables. Websites might load slightly slower because traffic is now taking a longer path. But nothing breaks. Nothing goes dark. The system just adapts in real time to route around the damage. And here's what makes this even more surprising. The protocols that make this possible were designed in the 1,970 seconds. TCP/IP, the fundamental language the internet speaks, is almost 50 years old. We've built countless new technologies on top of it, but the core routing logic that makes the internet indestructible hasn't needed major changes. It was designed so well from the start that it scales from thousands of devices to billions without breaking. And if you think that's wild, check this out. There's another layer that makes the internet even more resilient. It's called redundancy, and it means building multiple copies of everything. Major websites don't run on a single server in one location. They run on hundreds or thousands of servers spread across dozens of data centers worldwide. When you load YouTube, you're not connecting to the YouTube server. You're connecting to one server in a cluster of thousands, probably located geographically close to you for speed. If that server crashes, the network automatically directs you to a different server. If an entire data center loses power, traffic gets rerouted to other data centers. Google has data centers on every continent. Amazon has them in 30 different regions. Facebook's infrastructure spans the globe. You'd have to simultaneously destroy facilities in dozens of countries to actually take down these services. And even then, they'd likely rebuild faster than you could keep destroying them. Let me blow your mind for a second. Here's the uncomfortable truth about internet outages that nobody wants to admit. When a major service goes down, Facebook, Gmail, Netflix, it's almost never because of external attack or natural disaster. It's because of human error during routine maintenance. Someone pushes a bad software update. Someone misconfigures a router. Someone accidentally deletes a critical database. What's actually happening is that these companies are so good at surviving external threats that internal mistakes become the main vulnerability. Facebook's 6-hour outage in 2021, they accidentally made a configuration change that told all their routers to stop advertising routes to their data centers. Essentially, they deleted themselves from the internet's phone book. The internet was working fine. Facebook just made it impossible for anyone to find them. This isn't about the internet being fragile. It's about human systems being complex, and complex systems sometimes fail in weird ways. The internet itself, the underlying network, works so reliably that when services fail, it's usually because people broke something, not because the infrastructure couldn't handle the load. And once you see this, you can't unsee it. The scary outage headlines are almost never about the internet failing, they're about services built on the internet failing. And it's the reason why cybersecurity experts don't worry about someone taking down the internet. It's not a realistic threat. You can take down specific services. You can disrupt specific companies. But the actual internet, the mesh network of billions of devices with thousands of interconnected paths, you can't take that down. Not with hacking, not with physical attacks, not with anything short of destroying most of human civilization's infrastructure. Let me tell you about two IT managers dealing with an outage. We'll call them Jessica and David. Jessica works for a mid-sized company that hosts all their services on a single server in their office building. One Tuesday morning, a water pipe bursts. The server room floods. Everything goes down. Their website, email, customer database, everything. Jessica spends the entire week trying to recover data, dry out equipment, and get systems back online. Her company loses hundreds of thousands of dollars in that week. Jessica thought she was being smart by keeping everything in-house. We control our own infrastructure, she'd say. We're not dependent on the cloud. But what Jessica didn't realize is that by having everything in one physical location, she created a single point of failure. The one thing the internet was specifically designed not to have. And when that one point failed, her entire operation collapsed. Now compare that to David. David works for a similar sized company, but they host everything in the cloud across multiple regions. One Tuesday morning, there's a massive power outage in the Virginia data center where some of their services run. David gets an alert, he checks the status. Traffic is automatically failed over to their Oregon and Ireland data centers. Customers haven't noticed any disruption. By the time the Virginia center comes back online a few hours later, David hasn't even needed to intervene. The systems did exactly what they were designed to do. Notice how David didn't have better luck or more resources? He understood the fundamental principle that makes the internet indestructible: redundancy and automatic failover. No single point of failure. Multiple paths for everything. When something breaks, the system routes around it. Jessica was thinking about control and ownership. David was thinking about resilience and design. That mental shift made all the difference. Here's what most people don't realize. So, what's really going on here? It's not actually about having perfect infrastructure that never fails. It's about having distributed infrastructure that can fail partially without total collapse. The people who build resilient systems don't try to prevent all failures. They understand that failures are inevitable. So they design systems where failures are isolated, automatically detected, and routed around. And once you see it this way, everything changes. These patterns aren't about having massive budgets or advanced technology. They're about understanding that centralization creates vulnerability and decentralization creates resilience. The internet survives because there's no center to attack. Services fail because they create centers. Single companies, single servers, single points where everything depends on one thing working. But now that you understand that distribution and redundancy make systems nearly indestructible, you can see why the internet itself is basically immortal. So here's what we've uncovered. The internet is a mesh network with no center and no single point of failure. Data packets automatically route around damaged connections without human intervention. Routers constantly share information and adapt to failures in seconds. Major services run on redundant systems spread across dozens of data centers globally, and when the internet goes down, what's actually failing is one service built on top of the internet, not the underlying network itself. The question isn't whether the internet will survive the next major outage. Of course it will. The question is whether you'll recognize that internet outage headlines are almost always about services failing, not the internet itself having problems. Because now you know that the internet was designed specifically to survive catastrophic damage. It routes around failures like water flowing around rocks. You can't unknow it. So next time you see breaking news about a massive internet outage, ask yourself, is the entire internet actually down? Or did one company's services fail while billions of other connections keep running perfectly? Because once you see that the internet is a decentralized mesh network with thousands of redundant paths and no possible single point of failure, those scary headlines start looking less like technological apocalypse and more like what they really are. One company having a really bad day while the rest of the internet carries on just fine.